All right, question 1. For this one, this says to simplify 2 square root of 3 plus 5 square root of 3. Big thing is if we're adding and subtracting radicals, you have to have the same thing in the square roots. If you do, just add those two numbers. So that makes it 7 square root of 3. Everybody says, hey, can we have 22 of those, right? Well, no, we gotta give you something a little bit more than that one. All right, number 2. Changes it up a little bit. We get 4 square root of 75 plus 6 square root of 3 minus the square root of 12. Okay, definitely don't have the same square roots on these. All the radicals are different. So when your radicals are different, that's where you got to take the 75 and start breaking it down. And again, if you're not sure of it, how you want to break it down, there's all kinds of different ways. If you start going with 25 times 3, I'm going to pick on that one because if you do the square root of 25, that's a perfect square root. You can take that 5 out. So it leaves you with square root of 3. And the 4 that was here, that makes it 4 times 5 times square root of 3. Which would be 20 square root of 3. Okay, the 6 square root of 3, there's nothing you can do with that one, so we're going to bring it straight down. And square root of 12, same thing. If you take this one and start to break it down, it's 4 times 3. But you can take the square root of 4 to make that 2. So it's 2 square root of 3, that was a minus. So then minus 2 square root of 3. Okay, now they're all the same. So then you can go back and do the 20 plus 6 for 26, and then 26 minus 2 will make it 24 square root of 3. Okay, so a couple of questions there, just to have you add and subtract. Again, one with radicals the same. Next one, you got to take the radicals and break them down. And then question 3 kind of jumps from addition, subtraction, to multiplication. And multiplication is a little bit better because you don't have to worry about anything. Multiplication, you just start multiplying. Whatever the numbers are, multiply together. If you can simplify that number when you get to the end, you simplify it. 10 doesn't break down, so that's as far as that one will go. Okay, now number 4. This is one that you actually can break down a little bit. You've got square root of 24, and I don't know why there's an X in the middle of that. That is, to me, a little bit confusing. 24 times 3 square root of 98. Okay, now you can go back and multiply these together first. But if you look at a number and you go, well, I can break that number down, do that first, because if not, if we stick with the pattern you're supposed to do, you would multiply, basically you've got to understand one here. You would do 1 times 3 on the outside. Then you got to do 24 times 98 to get some number in the 2,000 somethings. So it's going to be really big. So before you do any of that, take the 24 that you get here and start breaking it down. And again, if you're not sure, so I know 4 goes into it, seems like there should be a bigger number that would go into it. Just start breaking it down. I'm going to go with the stack method instead of the factor tree. With 24, divide it by 2 to make it 12. 12 you can divide it by 2 to get 6. 6 you can divide it by 2 to get 3. So 24 is 2 times 2 times 2 times 3. There's your pair of 2's. There's your exit buddies. That 2 gets out. 2 times 3 on the inside doesn't have any other buddies, so they stay there. That's 2 squared of 6. Okay, same thing with the 98. You can take 98 and start to break it down. If you do that one, it's even numbers. So you divide it by 2. When you get to 49, well, 49 is a perfect square. It's 7 times 7. Pair of 7s, so you can take that 7 out. You're left with the square root of 2. Now, it did have a 3 in front, so it would be 3 times the square root of 7. So we have 2 square root of 6. You've got 2 square root of 6 times 3 times 7 is 21 square root of 2. So now you finally got those numbers broken down as much as you can, which makes the multiplying a lot easier. Now it's 2 times 21 on the outside for 42. On the inside it's 6 times 2, which is 12. But again, with 12, you can start to break that down to make it 4 times 3. Take the square root of 4, make that a 2, make it 3 on the inside. And the 42 that was in front was again multiplied. So it's 42 times 2, which is 84 square root of 3. Okay, so with multiplying, if you can simplify numbers down first, it's inside the radical. Do that part first so that the multiplication gets a little bit easier. Because if not, then you've got to go back and multiply 98 times 24 and then take that number and break it down. And then go from there. Okay. Number 5. Basically the same thing on number 5. The only difference is, well, 2 big differences. One, the numbers aren't near as big, but I guess the other big difference is they give you variables. Okay, and the only difference that you do, you still go ahead and do your multiplication here. So when you multiply these two together, 15 times 3 is 45. You've got 4x's and 5x's. The difference is when you do multiplication here, you're going to add those numbers together in the exponents, so make it x to the 9th. Okay, and then you can almost really do it in 2 parts. We're going to work on the square root of 45, and we're going to work on the square root of x to the 9th. 45, if you start breaking that one down, it's 9 times 5. And again, there's your perfect square root with the 9, so you can take that out and make that 3 square root of 5. And with the variables, what we said you got to do with the variables is you have to take this power and divide it by this index. They talk about pairing everything up and doing some things, but we said the easier thing to do is just divide 2 into 9. Goes 4 times with 1 left over. And with that part, we said this is the exponent that goes on the outside. The remainder, well, that's what's going to remain on the inside. Okay, so if we put it all together, we've got a 3 that's on the outside. We're going to have an x to the 4th on the outside. On the inside, we have the 5, and we have 1x that's left on the inside. Number 6. Same thing. The only difference on number 6 is instead of doing square roots, this one's third root. And by being third root, we're still going to go ahead and do the same thing. Now, again, if it's square roots, we would look to break this one apart because the numbers are relatively small. You know, compared to doing 24 times 98, these numbers are small. So go ahead and multiply those numbers together. 12 times 9 would be 108. And then we're going to take the 108 and start to break it down. Okay, again, if you want to go with the even numbers, we know 2 would go into 108, get 54 left over. 54 is even, that's also another 2, makes 27. 9 times 3 for 27, which eventually gets it to 3 to the third. Okay, so we've got 2 2s and 3 3s. Okay, and the only thing we're going to do with cube roots is this time you need everything in groups of 3s. There's a pair of 3s, so that 3 would come out. There's only 2 2s left over, so they'll stay on the inside. And 2 times 2 would make it 4. Alright, question 7. Just another multiplication problem. This time we're back to square roots, which is what most everything we're going to do is going to be square roots. The only thing different on number 7 is now you're going to have to do distributive property. Okay, so for this one, again, if you want to put 1 in front here, just for kind of having a coefficient in front, you can. It's 1 times 6 for 6, and then 6 times 6 on the inside would make that 36. For the second part of it, basically it's 1 times 1 on the outside. On the inside, it's 6 times 7 for 42. With that one, the 6 is good. Square root of 36 is 6. Square root of 42. Now, if you go back and break it down, it is 6 times 7, but neither one of those are perfect square numbers. And if you break down the 6, it's 2 times 3. So there's no perfect square roots that come off this one, so that one just stays square root of 42. So that one would be 36 plus the square root of 42. Okay. Goes from multiplication to division, and then it kind of goes back to multiplication again, so it kind of bounces around a little bit on these problems when we're going back and forth here. With number 8, it's the square root of 13 over the square root of 52. And again, it just says to simplify. Okay, and it's almost one of those where if they give it to you separate, you almost put it back together. That for this one, if you make it 13 over 52, well, if you check it real quick, you can divide them both by 13. So that makes it the square root of 1 over 4. And once you get it here, well, hopefully you're going, well, those are both perfect square numbers, so if you were then to kind of take it and break it back up, you can make it the square root of 1 over the square root of 4. That just makes it 1 over 2. Okay, so if they say just simplify, again, you're going to take the fraction and break it down as much as you can. You should come up with all the numbers should be basically perfect square numbers. When you don't get perfect square root numbers, it is what we get for number 9. This is where they tell you you're going to rationalize. You get square root of 5 over square root of 3. And as long as it's just one term in the denominator, all we're going to do is take that same problem that we have and multiply by the number in the denominator. Okay, if you do that, on the top part, you get 5 times 3, which is 15. On the bottom, we'll do 3 times 3, it's 9, but when you square it to 9, that makes it 3. So that's square root of 15 over 3. And again, square root of 15, if you break it down, it's only 5 times 3. That's the only way you can get there. Neither one of those are perfect square numbers, so that one would just stay square root of 15 over 3. Number 10, same directions on number 10. Still going to tell you to rationalize. Still going to do the exact same thing, whatever problem it is that they give to you. We're just going to multiply that by whatever you have in the denominator. Okay, top part, 2 times 3 is 6 with the W. And again, on the bottom, if you have the same thing twice, all we're going to do is take the square roots off and just make that a 3W. Okay, so it doesn't matter if you have a variable or not. If it's square roots and they tell you to rationalize it, you just multiply by whatever the number is that's in the denominator. That will always make that bottom number come out to be a perfect square root number, which just basically winds up being this number without the square roots. Top part, doesn't matter what it is. If you can break the top part down, you can. But honestly, when you rationalize it, you're not worried so much about the numerator. You're more worried about the denominator not being a square root where it's just a regular whole number. Okay, and then 11. Square root of v is equal to 7. Okay, if they give you a square root and ask you to find out what the answer is, to undo the square root, you're just going to square both sides. Square and square root cancel, get you the v. When you do 7 squared, that is 49. Okay, number 12. A little bit out of order from the other ones because this one's just back to regular simplifying. Square root of 54. So for this one, again, if you can think of a perfect square root that comes out of this one, you can go with it. If not, just start breaking it down. 54. Again, if you go with the stack method, you only put prime numbers on the outside, which is your 2s and 3s and 5s. So go ahead and divide it by 2. 27, you can divide it by 3. 9 would then be 3 times 3. So 54 is 2 times 3 times 3 times 3. And again, because it's square root, we're looking for pairs of 3s. So that 3 would go on the outside. You've got a 2 times 3 that would be left on the inside. Okay, and then 13 with this random number generator works out almost perfectly because the only difference between 12 and 13 is it's square root of 54, but now you get y to the 12. Okay, so if you separate this into two parts, you can take the square root of the number and you can take the square root of the variable. This worked out great because we've already got the answer right here for this one. It's 3 squared of 6. Okay, we'll just bring that answer down here to get what we need. For the second part, again, it is square root, means it's to the index of 2. If you take 12 and divide it by 2, go 6 times evenly. So we're going to take 6 y's and put it on the outside. There's going to be no leftovers on the inside. So this would be 3. We're going to have y to the 6th on the outside. And we're only going to have the square root of 6 that's on the inside. Okay, and then the next 1, 2, 3, 4, 5, looks like 6 questions would be, I think that back end of, this was the chapter 11 topics we had that we were solving, and then everything else is still going back to what we were doing back in chapter 10. So 14, it tells you to solve it. Where you get x squared equal to 49. And it just says x is a real number, simplify your answer as much as possible. Key thing is x squared, right? You're looking for 2 answers. Most people go, well, I know that if I do 7 times 7, that's 49. Okay, but then you have to remember that basically if it's x squared, to get it down to x, we're going to square root both sides. So we do get the x. When you square root 49, that's 7. To get the two answers, plus or minus. Because you could do a negative times a negative, which would make it a positive. So anytime you're working with equations, whatever that degree is, whatever your highest power is, that tells you how many answers that you have to have. Okay. And 15, the exact same setup, the exact same problem. They just change up the number so that it's not a perfect square root. So x squared equals 12, which seems like we've run across that one 2 or 3 times here. Same thing, we're just going to square root both sides. Left side we get x, and with 12, if you break that one down, that would be 4 times 3. There's your perfect square root. You can take the 2 out, leave the 3 there, so that's 2 square root of 3. And again, the only thing you have to do is, because it was x squared, we need 2 answers. Go back and put the plus or minus. Okay. And as long as it's just x squared and a number, it's always that. You're going to use this square root property. And it doesn't say, okay, it does not say that in the questions. It just says to solve it. I think in some of the homework problems it may have said to use a square root property, but it didn't here. But it's really, that one, as long as you get x squared and a number, you're just going to square root both sides. All right, 16. This is the one that they tell you to solve it. But you have to solve by completing the square. And this is the one that had the 2-part answers when we were doing this one the other night. Which was x squared minus 10x plus 20. Okay, and with completing the square, what we said you had to do, the very first thing is, you have to get the x's by themselves. You're going to take this 20 and basically get it by itself. Whether you say you're getting the x's by itself or the constant by itself, ever how you want to look at it, just separate the two things. All the x's go over here. The number that's by itself goes over here on this side. Okay, second thing you're going to do is, now that you've got these separated, you're going to take the b term that's here, this negative 10. You're going to divide it by 2. And then once you've divided it by 2, you're going to take that answer and then square it. So it's a 2-step process. So step 1, you go here, just take the b term and divide it by 2. Second step is, then you're going to take that answer and then just square it. Okay, once you've, and this is the completing the square part of it, once you get this 25, you're going to put that 25 and add it back to both sides. Which basically does 2 things. The right-hand side, you go ahead and give me that number. Negative 20 plus 25 would be 5. On the left-hand side, when you put this one in, this is where they want you to go back and then factor this part. And this is the completing square part that they put with this one. The factors of 25, negative 10. It's going to be this step 1 that we had back here, this negative 5. So this thing would factor off as x minus 5 times x minus 5, which really means it's x minus 5 squared, because you've got 2 of the same thing. And that's what makes it the perfect square part of it, or completing the square when I do that one. Now that you've got it down to something squared equals 5, then you can go back and take the square root of both sides. Okay, oh yeah, this is where we were doing it back here. In the homework and on the test questions and online everything else, this was basically part 1 of the answer. that they give you the box and you have to go back and fill it in. Once you get it down to here and you've got it down so it's x plus or minus something squared, they give you two choices where you do x minus, and then they'll give you a box here to go back and put in this number, and then you also go back and put a box in for that number. So you got to go back and fill in those two numbers, making sure that you pick the correct sign that's there, because they give one that's a minus and one that's a plus. So make sure you use the one that's a minus. Okay, steps in between, this is where you actually work this problem out. Again, if you square root something squared, the square and the square root cancel each other out. So this part becomes just x minus 5. And the square root of 5 doesn't simplify, so that answer stays there. Again, way back here in the beginning, we started off with x squared. We got to have two answers. We only have kind of one at the moment. So that's where we put the plus or minus. And then finally, one last step to get the x by itself there. We're going to go back and take this x and then add 5 to both sides. So then x would equal 5 plus or minus the square root of 5. Again, I do not think that that's an option that they don't give you that plus or minus button. So I think this is one that you have to go back and separate out the two answers. Yeah, you do. So again, online answer. You'd have to take this and go back and separate it. So one answer would be 5 plus the square root of 5. The other answer would be 5 minus the square root of 5. And on the answers that you have here, it's hard to see it, but that's what it's supposed to be. That was one I just didn't copy over very well. Okay, the good news is there's only one of those. Because all the other ones, it's honestly a little bit, I hate to say it's a little bit easier, but it's less stuff that you have to remember when we do the other problems that we have to solve. Because the other problems, when we get to 17, it tells you to use the quadratic formula. Okay, and your quadratic formula is this. Again, if you're not good with the negatives and the positives, the best thing in the world to do is to go back and take all these numbers that you would have and wrap it in parentheses. Okay, and we'll use that formula, I think, twice. We'll use it on 17, and then we also use 18. We're also going to use it on 19, because that was the word problem that we had that was there. Okay, so we'll use that one 3 different times. Okay, let's take that out, because that's not 17 yet. Okay, here we go. Here's number 17. Oop, not there. All right, try it again. Okay, 17. Use the quadratic formula to solve 2x squared plus 9x plus 5 equals 0. Okay, so from that problem, your A is 2, your B is 9, and your C is 5. So we'll take those 3 values for A, B, and C and plug them back in. And again, whichever calculator that you use, if almost all of them, it's pretty much the same thing, that if you'll take those numbers and use the parentheses, you're pretty much guaranteed that you're not going to mess this thing up. I mean, if you use the parentheses, there's not much of a way you can mess this problem up. We're plugging in the numbers. So it's the negative of b plus or minus 9 squared minus 4 times a times c. All that's over 2 times 2. Makes it negative 9 plus or minus, and I'll put this up here for us real quick. 9 squared would be 81. 4 times 2 is 8. 8 times 5 is 40. So that's the square root of 41 over 4. And for that one, these two numbers don't simplify. That doesn't break down, so that's your answer. And the only thing you would have to do, when I'm up against the bottom of the page here, the only thing you would have to do for the online answer is to go back and separate that into two parts. So one answer would be negative 9 plus the square root of 41 over 4. The other answer would be negative 9 minus the square root of 41 over 4. And again, if the radical doesn't break down, doesn't simplify, just leave it like it is. Some people like to wait, they don't have to think about it. It's just, okay, it's 41, we'll go with it. Actually makes the problem a little bit easier if it doesn't simplify. Okay, 18. The only thing they ask you to do different on 18, we're still going to go back and use a quadratic formula. With 18, instead of leaving the answers in radical form, where it says give the exact answers, it does say to then round your answers to the nearest hundred. So when we go back and do 18, we've got to take these two numbers and actually change them into decimal numbers to get what we're looking for. All right, and 18 is 9x squared plus 4x equals 1. Okay, and we're going to round to the nearest hundred. All right, first thing is, it does have to equal 0. So you're going to have to move that 1 back over to the left-hand side. And once it's equal to 0, then you can go back and pull out your A and your B and your C values. So for this part, your A value is 9, your B value is 4, and your C value would be negative 1. So those are the three numbers we're going to go back and plug in. Okay, so for parentheses, it was the negative of b plus or minus b squared minus 4 times a times c, and that was all over 2 times a. Okay, and again, the kind of good news on this one is because it's a decimal number, we don't have to worry about taking the square root. If it comes out to be something we can simplify, we don't have to worry about it because we're going to change it to a square root answer anyway, or to a decimal answer anyway. So this is 16 minus, actually plus, because we got a negative times negative. So that is 9 times 4 is 36. Divided by 18. So this is negative 4 plus or minus the square root of 52 divided by 18. Okay, and from there, just go ahead and do those two things. We're going to do negative 4 plus the square root of 52 divided by 18, and we're going to do negative 4 minus the square root of 52 divided by 18. And from there, it just becomes a calculator practice problem. Square root of 52, and again, you should be able just to pretty much, if you ignore the bottom part for a minute, just go ahead and do negative 4 plus 52 on your whatever calculator that you have. So for this one, that would be, square root of 52 is like 7.2. So if you take that 7.2, do -4 plus that, that should come out to be 3.211. You know, all those decimal numbers. And again, it doesn't matter what it is. Just go ahead and take that whole big thing that's here, and then go back and divide it by 18. So that one should come out to be, and this is when we'll round it, it's 0.178. So if we round it off to 2 decimal places, that's 0.18. Okay, do the same thing on the second one, but now it's -54 minus that, so it's a -7 and -4, so that's 11.211. Whatever numbers come after that, divided by 18. And again, we'll round it off to 2 decimal places, so that should come out to be 0.62. And there's your 2 answers that you're looking for. Oh, that wasn't negative. Now, and again, if you go through that one, if you're not sure how your calculator works, just let me know. I mean, it should be pretty straightforward, but if for some reason you're getting something different, just let me know, and there's usually just one little thing that may be happening along the way there. Okay, 19, same problem or same thing. You're going to use the quadratic formula, but in this case, they're going to give you a word problem. But again, the whole word problem comes down to using the quadratic formula. This one, you're throwing a ball. They want you to find the values for when the ball's height is 7 feet. So this is a little different than the one we did in class, because this time they tell you that h is equal to 7. Okay, I think the one last time was we were on the building and throwing the ball down. And, you know, that was when we had a positive time and a negative time. And we said, okay, you can't have a negative time, so we had to get rid of that one, instead of 1. In this case, this one's a little bit different because they don't say when is 0. This time they're saying, okay, this time you're going to use that the height is 7. They want to know how long is it going to take, what's the time going to be. So you've got to find out what the t-value is. But again, they're telling you your height is 7. So the only thing you have to do on this one first is you're going to take the 7 and plug it in for the h. And then the rest of it, then we're going to go back and work it out. Okay, and this one now looks like the problem before, that you've got to have this thing equal to 0. So first thing we'll do is we'll subtract 7 and move that back over here. So then you do get the 0 equals 3 minus 7 is -4. 17t minus 16t squared. Okay, and when you pull the ABC numbers out, it's always in the same order of the power. So this one, they've got it written in reverse order. So the -16 would actually be your A value. Your B value would be 17. And then your C value would equal -4. Okay, and that's the 3 numbers we'll go back and plug in to the quadratic formula. And this one, another one where it said to round the answers, so we'll go back and use a decimal number on these. Okay, so we'll go back and plug in this case it was t, so technically we'll need t instead of x. But we'll go back and plug in the numbers here. The b value is 17, so that's 17 squared minus 4 times a times c. And all that's over 2 times 8. That's -17 plus or minus the square root of 17 squared is 289. 16 times 16 is 256 over -32. Again, because we're going decimal numbers, we just need to get this down to a number that would be 33. And once you've gotten that to a number, then just go ahead and break it up into two parts. So one time we'll have negative 17 plus the square root of 33 divided by negative 32, and then the other time we'll do negative 17 minus the square root of 33 divided by negative 32. Okay, and again, it's from there. It's just working with your calculator. 33 square root. We're gonna do that. Negative 17. That's negative 11.255 something 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 goes on there. Divided by negative 32. That comes out to be rounded to the hundredths place. That's 0.35. All right, on the bottom, you got that square root of 33 again. It's negative 17 minus the 5.222 part there. So this one comes out to be 22.744, and everything that came after there, divided by negative 32. Again, negative by negative makes it positive, and dividing those two numbers, we get 0.71, rounded off. Okay, now, and this was your time, and basically the way, if you can look at the ball, the way they've got it thrown here, they're saying that you're going to take this ball that you have and you're going to throw it so it does something like this, and they're asking you, okay, when's it going to be 7 feet above the ground? It's going to do it twice, right? It's going to do it once over here, and then once along the way back down. So this first number would be where we've thrown it, and then, boy, that's a fast one, isn't it? 0.35 seconds and 0.71 seconds. So it's just going to be like that. So it's basically somebody just almost dropping it. Somebody's not throwing it very hard. We got a 1-year-old throwing that ball. Okay, so again, just playing around with the numbers, just have to kind of watch and see. And again, if it had been, this was the time we had, and again, as long as the numbers come out to be positive, we can use both of them. The last time we did this, we were doing time, and it came out that one of the answers was negative. And again, you cannot have a negative time because you're not going to throw it back to the future, back in the past. So just have to kind of pay attention to which ones you're kind of looking at there. Okay, number 20 gets us back to some problems that's not so much with word problems in the quadratic formula. That 20 is back to just another normal kind of problem. This one you're simplifying the square root of 24 to the 21. Okay, so that one, we'll break it up in two parts. We're going to do the square root of 24, and we're going to do the square root of v to the 21. 24, if you start to break that part of it up, 24, the only perfect number you can divide out of it would be 4. So if you take the square root of 4, that's 2. The 6 is going to stay on the inside, so that makes it 2 square root of 6. For the v, again, it's square roots, we're going to divide it by 2. So divide 2 into 21, that's going to go 10 times with 1 left over. So we're going to put a 10 on the outside, and we have 1 that's left on the inside again, and that's going to be our exponents that we're looking for. So if we put that back together, it would look something like this. And again, putting those two things together, we've got a 2 and a v to the 10th on the outside, and we've got a 6 and a v on the inside. So that would be the final answer that we're looking for. Okay, 21. Kind of along the same lines, no variables in this case, but this one's fourth root. So this one goes back to the one we were doing earlier that was the third root. This time we're looking for everything in groups of 4s, which we don't normally think about a whole lot. So this is one where you're just going to have to take the 96 and break it down. Probably going to be a lot of 2s and 3s more than likely. Definitely a lot of 2s here. Divide 96 by 2, that's 48. Take 48 and divide it by 2, that's 24. Take 24 and divide it by 2, that's 12. Take 12 divided by 2, that's 6. Take 6 divided by 2, that is 3. Okay, so we got 1, 2, 3, 4. Now, and honestly, again, this is one of those where if you want to, you could kind of breaking these up. If you know you're looking for a group of 4, there's 1, 2, 3, 4 2s right here. So that's going to force that 2 on the outside. You're then left with 2 times 3 that doesn't have any exit buddies. They're stuck there. So that 2 and 3, we're going to multiply together and leave it on the inside. Again, if we're doing that part with the fourth root, taking out the 4 2s, where we get that 2 that goes on the outside and that 2 times 3 is left on the inside. Okay, 22. Biggest thing on 22 is it doesn't say to solve it. This one just says, doesn't say rewrite, it just says write it as a radical expression. Which means you're not going to do any solving, you're just going to change it from exponent to radical. Okay, and all we said you're going to do is, to make it a radical, of course, that means we've got to have this part with the z. The bottom number, that's your index, it goes on the outside. Top number is your power, it's going to stay on the inside with the 5, or with the z. Okay, 23, they want you to simplify. And for this one, because it's in exponent form, it's basically the opposite of this one. They want you to change it, well, actually, sorry, it's the same thing as this one, that it's in exponent form, they want you to change it back to a radical, and then go back and work with it from there. Okay, if you're right, that is the fourth root of 16 to the third power. And it's easier to do the fourth root of 16 first, so let's do the fourth root of 16, because 16 would be 2 times 2 times 2 times 2. And then you can put the third power, again, third power is kind of optional. You can put it on the inside or you can put it on the outside. It's kind of in that no man's land where you can kind of go either way. That if you have the fourth root of 2 to the fourth, well, there's that pair of 4s, you can take this 2 out, everything is gone. So now it's just 2 to the third power. 2 times 2 is 4. 4 times 2 is 8 for your final answer. And same thing back here when we did this one. This z, the sixth root of z to the fifth. That fifth power is kind of straddles the fence. You know, you don't know if it's a Democrat or Republican since we got elections coming up. It's kind of, you know, throwing a little bit out there. We like health care, but maybe it's not for everybody. You know, it's, you know, one of those kind of things where they're kind of trying to straddle the fence and they got to decide. Same thing here with this one. It's the fourth root of 16. You can put the 3 on the inside, but you can also say, well, let's just put it on the outside here and see what happens. So you can kind of go back and forth on that. Okay, and there's only, I think those are the only ones where you have to go back and rewrite problems from radicals to variables. Or radicals to exponents. Maybe there's one more here. No, there's not. That's only 2. Alright, 24. Another solving equation, but this one's a little bit different. because this one we have a square root instead of having x squared. All the other problems we had x squared, this time we have square roots. And with any of the radicals we were doing, the very first thing we said you had to do is you have to get this radical by itself. So this minus 2 that's attached to it, go ahead and add that 2 to both sides so we get just the square root on one side by itself. All right, and this is where you can check. If this 3 was negative, that's when you would stop and say no solution. That when we're doing these, it always needs to be a positive number. Because that would give us, if it was a negative number, it's one of those extraneous solutions where it's a number, but if you go back and check it, it actually doesn't work. So this is one of those where that's got to be a positive number. If this is a negative, you can just stop and say it's no solution. But we're positive, so we're good to go. To get rid of this square root, we're going to square both sides. Okay, and when you square the square root, all that goes away, leaves you with just what you have on the inside, which is the radicand. And now you've got just a regular normal expression. From here, we can add the 26 to both sides. So we get 35 equals 5y. So divide 35 by 5, that gets us y equals 7. Okay, and again, it's one of those, if you ever wanted to be safe, you could take that number and plug it back in. But as long as it's just a square root and a number, we're pretty good. The only time we really have to go back and check it is if this had been an x out here, or in this case a y, because y was a variable. If that had been a y out here instead of just a number, that's when we have to go back and start checking it, because it may or may not work depending on how the numbers work out there. Okay, which runs us right into question 25, because it just said exactly, does exactly what we just got through saying. 11y minus 18 equals y. Okay, good news is the square root is by itself. So we're going to go ahead and just square both sides. Again, the part that makes this one a little bit dicey is that it's not just a number over here that we get this y. So now we get y squared. The square and square root cancel. That's 11y minus 18. Okay, if it was just a number, we're okay. We would go back and solve the number, but because it's y squared, now we're looking for two answers, because this is what we have to solve. So that means we have to either do the quadratic formula, which will take a while, but again, on these problems, it should be that it's factoring. So to make the factoring work, let's move everything over here with the y squared. And we'll do basically two parts of one here. We'll move the 11y over here by subtracting it. We'll move the 18 over here by adding it. So that should get us 0 over here. Y squared minus 11y plus 18 on the right hand side. Okay, and again, two choices. You can do quadratic formula, which I suggest you don't do, because you can do it, but it's going to take a while. Easier thing here should be to factor. Unless you don't like factoring, then you can do the quadratic formula. Okay, and they pick numbers here that should be really easy to work with, because it should be the factors of positive 18, where the sum's going to equal negative 11. Okay. It's not 1 and 18. 2 and 9 might work. 3 and 6 definitely not going to get you there, so it's got to be 2 and 9. Be careful with your signs, because that b term is negative, which means the bigger number has to be negative. If you divide a positive number by a negative number, it forces the other one to also be negative. So it is negative 2, negative 9. Okay, so we've got y minus 2 and y minus 9. solving both of those. The solving gets really easy because we'll add 2 to both sides. This one we're going to add 9 to both sides. So we get y equals 2 and y equals 9. Okay, but again, have to check the answers. If you get one that's negative, that's definitely a red flag. Both of these were positive, so both of them might work, but we got to just double check it and make sure how this thing sets up. Because again, sometimes they look good, but then when you go back and check it, it may be that they don't work out quite like we thought they should. Okay, so that was our original problem. We're going to take this y equals 2, plug it in here, and see if it actually works out to be what we think it's supposed to be. So it's the square root of 11 times 2 minus 18. And again, the question is, does that equal 2? It's 22 minus 18. That is the square root of 4. Square root of 4 does equal 2. Okay, so that one checks. So we're good there. Okay, we'll do the same thing. This time we're going to use the 9 and plug it back in. Square root of 11 minus 9 minus 18. Again, the question mark is, does that equal 9? It's 99 minus 18. That is the square root of 81. Square root of 81 does equal 9, so that one checks also. So both answers work, so both answers are good to go. So it is 2 and 9 for the 2 answers we're looking for. Okay, and you get rewarded for 26. So work on 25 because 26 is one of the easiest questions on here. What's the square root of 36? There you go, just that easy. Now, and key thing on that one, it said, what is the value? And this is where your English is going to help out, because if it's what is, that means is goes with one answer, right? If it said what are the values, that's where you'd have to do the plus and minus. But this one, it just says what is, so you're only looking for one answer, you're just looking for 6. I think the questions here, I don't think there's any that says what are. I think they pretty much leave the whole plus or minus out unless you're solving and you have the x squared there. So good on those that they don't, none of those questions pop up here. Okay, into the home stretch. 27 is a right triangle. It says find out what x is. Okay, so this one we're going to do Pythagorean theorem, and again, the two parts connected by the right angle, those are a's and b's. So your formula is a squared plus b squared equals c squared. And again, these two things are your a's and b's, so that's going to be x squared plus 11 squared. C squared will always be the number that's over here by itself. And from there, it's just use your calculator. 11 squared is 121. 16 squared is 296. Is that right? Oh wait, that's not right. Seems like it's too big. Hold on, let me double check it real quick. So 15 squared is 225. No, it's 256. I'm sorry. Even when I said it, that didn't seem right. Okay, how about 256? Okay, and to solve for x squared, we're going to subtract the 121 from both sides. So x squared would equal 135. And for this one, they're going to tell you to round the answer to the nearest hundredth, which means once we get it to x squared, to get it down to x, we're going to square root both sides. Okay, the good thing with this one is it's a distance, so we don't have to worry about the negative numbers, because if it's a distance, it cannot be negative. It's got to stay positive. From there, we're just going to square root 135, round it off to 2 decimal places. That should be 11.62. All right, 28. Another easy one. It's the square root of 49 over 36. Well, square root of 49. 36. Just separate the two out. Square root of 49 is 7. Square root of 36 is 6. And there you go. That's all you can do. So if they're both perfect square roots, it comes out to a nice, easy little fraction. Okay, 29. Almost as easy as 28, or I guess they're almost about the same here. It's negative 3 to the 4th power. What's the square root of that one? Go ahead and do negative 3 to the 4th power. This is 81. Square root of 81 is 9. Okay, and that was part A. Part B, basically the same thing. It's the square root of negative 10 squared. If you do negative 10 squared, that is 100. Square root of 100 is 10. $30. Still another easy one here at the end. 64x to the 12. Break it up into the two parts. It's the square root of 64, and it's the square root of x to the 12th. Square root of 64 is 8. X to the 12th, again, that's the square root, so basically you're taking 2 and dividing it into 12. It goes evenly 6 times. That's x to the 6th. So again, 6 goes on the outside. There's nothing left on the inside. And it says make sure all variables are positive, so we'll make the whole plus or minus on this one. It's just the regular square root. Okay, 31. Third root of 8. Again, it's third root, so we're looking for 3 of a kind. If you take 8 and break it down, 4 times 2, but then you can take the 4 and break it down, so it's 2 times 2 times 2. Well, there's your 3 of a kind. There's nothing left over. So it comes out to be just a perfect 2. You could also think about it that, again, if you want to kind of think about it this way, it's the third root of 2 to the third. Again, as long as these two things match up, they knock each other out, and again, it just takes that number out every time. And last problem, which is good because we're right at the end of the page here. 32 just says to simplify. Okay, and then wait to the very end to bring back in the negative numbers that's inside, that's where we're going to use the imaginary numbers. Negatives on the outside, no big deal. We'll just work it out, do what you have to do. But if it's negatives on the inside, you have to do 2 things. The biggest thing is that where you have a negative, we said that for these parts, this is where you're going to have that I squared was going to equal negative 1. And again, the only difference was if this was square root of 4, that would be 2. But since it has a negative, that negative is like a marker that says, all right, it's not a real number. So on both of these, if we took the square root of 4, that would be 2. But because of the negative, we have to put an I there for each place. Okay. Same thing on the second one. You have that one that's a negative. So you're going to put an I there. Square root of 4 is still 2. If you go back and multiply it all together, You have 2 times 2, which is 4. You have I times I, which is I squared. We're going to come back to this thing again because we get an I squared here, so now we're going to take this I squared out. Place it with negative 1. So 4 times negative 1, and that would be a negative 4. Okay, and then part B was negative square root of 30 over square root of 5. Okay, for these two, if you divide these two numbers together first, because again, you can almost, if they're two separate fractions, you can put the fractions back together as one number. So really it's negative 30 divided by 5, which is the square root of negative 6. Okay, the 6 doesn't break down because that's as far as that one would go, but again, that negative on the inside is basically a marker like we had back here, that if you have that negative on the inside, that means the answer has to have an I in it. 6 doesn't break down, so it's going to be I times the square root of 6.